So today we're going to look at how can we sort of decide what way we need to factor or what's going to be the best approach to factoring a problem that we're given. And while we've talked about how to factor sort of in individual cubby holes, today we want to open that up and sort of throw them all into one bowl and be able to mix them up together. So this is sort of our what to use when. How do we know what way to factor? Okay, and when are we going to use it? And there's one type of factoring that we should just always consider across the board. It's sort of just the first place our brain should go. The first question that we always want to ask ourselves is, can we factor out a GCF? Okay, this is just a good first check. Okay, because whether it's two problems or 2 terms, 4 terms, or 100 terms, a GCF is always something that could happen. Okay, so whether it's something simple that's 2 terms or maybe more complex. Okay, so students might look at this and think, okay, I see 3 terms, I should do 6 times 8. But again, this isn't matching the format of ax squared, right? So just sort of always checking for that GCF first, okay? So if we look at this, right, 6, 5, and 8 don't have anything that will go into all of them, but they do all contain an x, and so we can factor out a GCF of x. Okay. So step number 1, can we factor out a GCF? If we can, that's the route we're going. Okay, the second step that we're then going to do is we're going to count the number of terms. If we count the number of terms and it is 4 terms, right, 4 terms we want to factor by grouping. So I'm going to sort of do a run through here and practice one of each type. So when you're doing your assignment today, you'll sort of have some reminders of every single form. So something with 4 terms, 10x to the third plus 35x squared plus 8x plus 28. All right, and when we have 4 terms, when we're factoring by grouping, this is where we want to split it in half and do the GCF on each side separately. Okay, so what goes into 10? That will also go into 35. You can pull out a 5. They both have the x. The smaller one is x squared. So I'm going to divide that out. Sorry, I forgot to write my 2 there. Okay, then I'm going to look at the other side. Okay, what goes into 8? That will also go into 28. You can pull out a 4. They do not both have the x, so I can't pull that out. And then remember, our 2 GCFs that we pulled out go in front, so I'll have a 5x squared plus 4 and a 2x plus 7. And that will be our final answer. Okay, now we could also count the number of terms. Okay, so if we count the number of terms and it's 4, we're going grouping. But we might also count the number of terms and there might be 3 terms. Okay, if there are 3 terms, then we want to factor it like a trinomial. Okay, so remember, a trinomial is where we're multiplying a times c, and this comes in 2 different forms. So we could have x squared plus 8x plus 15. Okay, so 1 times 15 is 15. I'm listing my multiples, right? 5 is already there, and then we want the set that will add up to b. So 3 plus 5 is 8. So this is going to go into 2 binomials. Now, the reason I know I can go directly to 2 binomials is because a is equal to 1. I don't see anything in front of x squared. A is 1. Okay, so I'm going to have an x and a positive 3 and an x with a positive 5. Now, while we start the process out the same, okay, a trinomial could also be where a does not equal 1. So 2 times 5 is 10. 1 and 5, or 1 and 10. 2 and 5. 3 and nothing. 4 nothing. Okay, so while here my set is 2 and 5, right? Remember, I can't use the shortcut here, and I have to split this up and write it into 2 terms. So this is going to be a positive 2y and a positive 5y. And then I have to split in half and factor by grouping, right? So GCF is coming out over here. And my GCF is coming out over here. Okay, my 2 GCFs go together. Now again, I'm just doing this as a reminder. If you need to see this from the beginning, you'll want to go back and watch how to factor by grouping or to how to factor trinomials where A is not 1. Okay. So here's where we're at so far. If we see a problem, we're looking for a GCF. Okay, if there's no GCF, then we're counting the number of terms. So 4 terms is grouping, 3 terms is a trinomial. But now what happens if we count and we get 2 terms? Okay, so if there's 2 terms, we're going to have to check, because remember this has more rules, but we're going to check for a special case. Okay, and a special case was when we had something like 4w squared minus 25. Right? It's 2 terms. It's subtraction. And they're both perfect squares, right? I take half of the exponent. 2 times 2 is 4. And 5 times 5 is 25. So I'm doing in the same order where 1 is addition and 1 is subtraction. Okay, so when you're doing your assignment today, it's going to give you a random problem. Instead of you just sitting there and saying, well, I don't know how to factor this, right? What way? It's not going to say factor by and then tell you what to do. You're going to have to go through your list. So step 1, can we factor out a GCF? So can we think of a number that goes into 12 that also goes into 8? Well, in this case, yes, we can. They both have the variable, so I'm going to pull out the smaller exponent. Okay, I'm going to divide this out of each of them. 12 divided by 4 is 3. Subtracting the exponents. 8 divided by 4 is 2. Okay, maybe you see a problem that says x squared minus 2x minus 48. Okay, you're going to check. Is there a GCF? No. How many terms is there? 1, 2, 3. Okay, well, 3 terms tells me to do a trinomial. So that's 1 times negative 48. Right? I'm ignoring the 48 for a minute, or the negative, and I'm just thinking of it as a 48. 18, 6. See, 5, and that, right? You'll just have to stick out the list. Now, then you might need to look in your notes and say, okay, what do I do with negatives when I have one subtraction and another subtraction? And when we were in that situation, we said, okay, we need the left-hand side to be positive and the right-hand side to be negative. Okay, this has a is 1, so that's a shortcut. So a plus 6 minus 8. So every time, you're just going to have to sort of check and see, is there a GCF? Or how many terms are there to decide which approach you want to use to factor.